All right. Okay, so let's talk about a particular example of a discrete, of a useful discrete probability distribution. So this probability distribution, as you can imagine, I made up, and but nature sometimes, a lot of probability distributions come up very, very often, and one place where it's very, very a very commonly occurring probability distribution is when you have what is known as a Bernoulli trial. A Bernoulli trial is is basically when you have a random variable, which is a discrete random variable, which can take two values. Okay, so it can take either 0 or 1, or on and off, or head or tail. Okay, and you have n instances of x. So you can think of it as flipping coins. You're flipping the coins, but you're flipping it n times. And it doesn't have to be a fair coin. So head and tail don't have to have half and half. Head can be p, tail can be q, so that p plus q is 1. And now the idea is that suppose you flip it n times. The idea is that what is the probability that of those n times, small n, sorry, hang on. Let me make sure I have my, yeah. So the question is, of those n times, how many times r times, say, what is the probability that of n times that you get head r times, right? What is the probability of that? Okay, so that's kind of easy to find out. And so if the probability of head is p, so this is, say, the probability of head, and q is tail, then if you have n trials, the probability of having head r times is going to be p to the power r times q to the power n minus r. This would be a specific way that you can have r heads and r heads out of n trials. This is the probability that you can have. Say, suppose that you say, okay, I want what the probability is, say, in a particular order, but I want to have r heads. But of course, the probability of this happening there are many different ways of this happening. So you have to count that too. And that factor is precisely going to be factorial n divided by factorial r n minus r. Okay, so this is precisely the counting that we did when we were talking about combinatorics. Okay, so this is going to be the probability that out of n trials we have r heads. Okay, and so we can write this in a shorthand notation, p and r, as n choose r times p to the power, p should be small here, p to the power n minus r, and then 1 minus p to the power r, or q to the power r. Okay, and this distribution is called the binomial distribution. Okay, so the p of n of r as a function, So this is not normalized. If you normalize it, and if you consider this as a function of r over n, of course, then this goes from 1 to 0, right? Because r cannot be greater than n. Then you can have, this distribution is known as the normal distribution. And it actually looks very much like the Gaussian. So it looks something like this, and it'll depend on how many, the larger n is, the more narrow this becomes, okay? Okay, so I will give you a picture of it in the lecture notes. You can also find it in bundle. So this is the normal distribution. And as you know, the normal distribution occurs naturally in the expansion of, say, p plus q to the power n, right? If you take the rth term on it, this coefficient, this is basically what you get in the rth term of this expansion of this guy, right? And what is this? This is just 1, because p plus q is 1. So that what you have here on the right-hand side is all the, the sum of all the probabilities, okay?
Sir, what's the difference between a normal distribution and Gaussian distribution?
A normal distribution, you can see, is a discrete distribution. A Gaussian distribution is actually a continuous distribution, and we'll come to that, okay?
Yes, sir. Thank you.